Okay, worksheet 32, and this is the mock exam 2. All right, we start off with this question. Now, I will be going through fast. I'm not going to spend too much time on those questions that you have no problems with. Okay, so the first two MCQ, in fact, I see that all of you can do it. Yeah, so not going to spend too much time. In fact, these are like giveaway kind of question. You're not supposed to make mistakes for questions like this. Are you seeing my slides? My question 15 is your question 1. All right. So a boy is wearing a helmet that protects the head. You know that this helmet serves its own function because it has a certain property, which is strength. Very strong. So it prevents this child from falling and hitting his head and getting hurt. Okay, question 2, which is 16. John carry out this experiment on 4 magnets. This is like a P3 question. Very simple, right? Straightforward. So the stronger the magnet, the more number of nails it can actually attract. So answer that is correct for this particular question. We know that this is D. Okay. All right, D, because P must be the strongest over here. All right, the rest of the statements are not true. I don't have to go through. I think all of you are good at this. Oh. Okay, I think, yeah, we can go on. Now, question 17. Question 17, which is your question 3, I will need your input. I will need to tell me, how come some of you actually got this wrong? Okay, explain to me. Explain to me why you chose this. Okay, those of you who actually chose, yeah, Miko, I saw. Can I just key in for you? I can, right? Yeah. Okay, question 3. Those of you who got this wrong, in fact, those who got it wrong, you selected B. 3 people chose B for this one. How come? Okay, how come B is wrong? How come you chose B? Sorry, I want to know. Like, for example, Denise can share with me. Hey, my slides jumped. Okay, back to this. How come you all chose B? Alex also chose B. Would you like to tell me? Okay, yeah. All right, I understand why you say that. Okay, Hannah. Yeah, but if you notice, this wooden block is extremely small. Okay, it's extremely small. If you try to test it out yourself, right? If you try to test it out yourself, do this setup on your own. Next week is when you have your 1 week break, you can actually try. Yeah, Alex, you are writing the same thing because it's right in front, nearer to the light source, right? So you thought that it's going to have a very big one. Okay, yeah. So if you try it out yourself, you can maybe even use the wooden block as, you know, the dice, right? From the games. Try that. You'll be able to test out and see that it's not going to happen this way. And anyway, the rubber ball, if you look at it very carefully, it's not really round. Okay, it should be round. Okay, and then answer is actually A. Okay, answer is actually A. Now, in the exam, if you were to ask me, then how will we know a mistake in the exam, how the size will look like? It's not going to be this complicated. Yes, you can edit the document today, but I want everybody to be careful, okay? Do not accidentally go to someone's cell and then you change the answer. You can edit, no problem. Yeah, to my P6, I'll be very nice because exam coming out, you realize that when exam coming, I'll get nicer and nicer to all of you, give you more attention because it's important. You need the support instead of, you know, scolding. Scolding doesn't work one. Okay, it has to be a lot of support and understanding. Things work that way. All right, so question 18. Question 18 is your question 4. It seems to be okay. Now, at least just now I heard your explanation. about the light one, so you understand already. In the exam, PSLE exam, it will be very obvious. It's not going to be something so ambiguous. But if you were to test it out during the 1 week break, I'll be doing some experiment, videoing, okay, and putting up on my Instagram page. I will be sharing with you the link so you can see some of the experiments that I do. Is all related to science concept. Back to this question. Okay. Let me see how many errors first. One, two. Oh, only one error. Good. Okay. Now, do you understand this part about beaker A and beaker B? Beaker A are filled with water up to this level, 200 ml level. Okay. I think Tommy is having a very difficult time with that. Is it Tommy? No, not Tommy. Oh, it is. Is everything okay, Tommy? Yeah. If you still can't have a proper connection, it's fine. Hannah, don't worry. Next Sunday, we are still having class, right? So next Sunday, I will share the link to my page. Let me just start off. Now it's nothing there. It's empty. Let me just start off with one simple experiment. I video it, then y'all can take a look. I may even video to discuss questions also. Okay. It's my own Instagram page for science only. Won't share anything about my life. It will be, maybe I start off with private first. I have not decided private or public. Okay. It depends. Should be public because it's science related. Nothing personal. Yeah. Okay. Now back to this. The next beaker, I actually have this. Oh, I don't like this. How come it jam all the time? I actually have this 200 ml height again, but it's filled with small stones. Now, tell me something about small stones. Okay, when I put these small stones into the beaker, do you think all the spaces are filled up? Yes or no? Wow, Hannah is fast. No. Why? Why? Why is that so? Yeah, because they are solids. The shape that they have. Yeah, very good. You're mentioning about shapes. The shapes that they have leads to small gaps. Small stones are, oval, round. Yeah, thank you for saying this. So if I were to draw, okay, these are the air spaces. Can y'all see? These are the air spaces because these small stones, all right, having their fixed shape already, right? They will lead to many small spaces being formed. Even here we'll have some, right? Here and there, because they don't completely touch each other. The surfaces cannot completely touch each other. There are a lot of small spaces. So when I pour this water in, the water is not going to go up all the way to this level. It's not possible. Some of the water will fill up all these air spaces. So maybe you can have water level up to here. Agree? Yeah. So it's going to be between 300 and 400. If you can understand this, let me know. Yep. Displaces the spaces. All right. Previously occupied by air. Thank you, Hannah. That's correct. Yeah. Good. Yep. Thank you for telling me you understand now. So let's go on. This is very important. Next, question 19. Let's see. Yeah, Brian also understand. Good. Yeah, true, Hannah. That's true. So realistically, looking at it. This should be question 5 now, right? Question 5. So this is your question 5. Maybe I just indicate. So it's easier for those of you who suddenly, start thinking, why is it question 19? So this is your question 5, my question 19, because mine is from the full mock paper. Peter put same amount of cold water into styrofoam cup and plastic vase. When he touched them, his hands felt that the plastic vase was colder than the styrofoam cup. Which of the following explain why Peter's hands felt that the plastic vase was colder? Must know, this actually is about how heat is conducted away from the hand. Okay, so this question is about how the heat is being conducted away. If you want heat to be conducted away, okay, you must talk about that particular material, whether it is a good conductor of heat or not. We have conductors of heat we can compare, right? So which is a better conductor, which is not so good a conductor. So in this particular case, it is very obvious which one is a better conductor. If your hand can feel cold, that means the heat is being taken away, right? So heat was conducted away from your hand more for the plastic vase. So the plastic vase is a better conductor of heat compared to the styrofoam cup. Do you agree? Can you understand when I explain it this way? Okay, so this question is about how much heat is conducted away from your hand or how fast it is being conducted from your hand. So which is your answer now? If you were to read one more time, which will be your answer? Okay. Then later I'll explain why certain option is not right. Okay, answer is definitely B. So plastic vase is a better conductor of heat, so it conducted heat faster. All right, compared to the styrofoam cup. This is definitely wrong. Plastic vase cannot be at lower temperature because why? Each of them are containing same amount of water and the water is at the same temperature. So you can't say that one is hotter than the other or colder than the other. No, they are the same. Plastic vase had more contact. No, you look at how the hand is holding on to each of the item. Okay, it's full grip, so cannot compare this way. So there's no such thing as more contact. Now, option A could be the one that you guys are actually struggling with. Yes or no? Yeah? Are you all struggling with option A? Now, gain heat. All right. So gain heat sounds something similar to good conductors will actually help to move heat from one place to another faster, right? So if you want to talk about gaining heat, you see, gain heat slower from your hand compared to the styrofoam cup. If it gain heat slower from your hand, it's taking heat slower from your hand, right or not? So your hand will not feel cold. If let's say the plastic vase gain heat slower, that means it is a poor conductor. Clear? A poor conductor, but the plastic vase is in fact a better conductor. Can you all write that down? Okay, the plastic vase is a better conductor. They are playing with words to make you confused. You have to be very strong in your own understanding of these concepts. So, conductor of heat, we can talk about very good conductor. Okay, we can talk about poor conductor. Can we talk about bad conductor? Can we talk about insulator? Tell me. Yeah, the vase should be gaining heat faster from the hand. Yeah, Hannah. Okay, so we cannot talk about bad conductor. Please do not use the term bad conductor. Please do not use insulator. Tell me why. Brian, you check online, huh? Plastic is a better conductor. Okay. Insulator is meant for electricity. Yeah, correct. Yeah, you don't say insulator of heat because there's no such thing as insulator of heat. It can reduce only, everything gains and lose heat. Okay, some are faster, some are slower. Very good, Wilma. You're right. So some are faster, some are slower, but there's no way you can stop heat from flowing, yes or no? So insulator, Insulator means the heat can't even flow, No such thing. We can only reduce heat loss or reduce heat gain, but we can't